Welcome back to the deep dive. We're doing our specialized analysis, digging into the latest intelligence from AI Brief, episode 274. And this week, wow, the frontier isn't just moving fast. It feels like the whole rule book might be changing. We're seeing this relentless, high volume model release strategy coming out of the East. And then there's a really serious, kind of formal challenge to how we even measure these models in the West. And underneath it all, a colossal infrastructure race. We're talking billions of dollars, huge amounts of physical space. So our mission today is simple: give you the shortcut to understanding these defining moves. We're going deep on Alibaba's Qwen 3 Blitz, Scale AI's new Seal Showdown, and Sam Altman's big plans for building AI's physical future. You know, for the last few years, we sort of got used to Western AI labs giving us these slow, measured releases, quality over quantity, maybe one big model update every 6 months or so. But Chinese tech giants like Alibaba, they seem to be just throwing that playbook out the window. They're operating at this rapid-fire pace. It's forcing everyone else to react, like instantly.
It's fascinating, isn't it? The sheer volume, but also how deliberate the specialization is. It's not just random. I mean, in just 1 week, Alibaba dropped 6 new Qwen 3 variants. Text, vision, audio, safety applications. The whole spectrum. This speed, iterating and deploying these specialized tools, it puts a Chinese lab closer to the absolute frontier than we've seen since maybe DeepSeek R1.
And these weren't just minor updates, right? Tell us about the main one, the Qwen Max.
Right. QuenMax is the big one here. It's a 1 trillion parameter model, and it's showing near-frontier capabilities, particularly in things like complex coding and agentic tasks. But the really interesting bit, its heavy version scored perfect scores on several key math reasoning benchmarks. That's just a really high level of logical reliability, which, is crucial if you want an AI to operate autonomously.
Perfect scores in math reasoning. Okay.
And beyond Max, there's Qwen Omni. That's their end-to-end, multilingual, omnimodal model. Handles text, images, audio, video, understands speech in 19 languages, generates it in 10. Plus, you've got specialized models like Qwen VL, now ranking as a top open-source visual model for non-reasoning tasks. And tools like Live Translate Flash for real-time interpretation. They're covering a lot of bases.
So if I'm understanding this right, they're not trying to build one single model to beat, say, GPT-5. It's more like they're trying to surround the competition, flood the market with these optimized, specialized tools.
Exactly. That seems to be the strategy.
But isn't that incredibly risky? Dedicating huge resources to these narrow capabilities that might be obsolete in, 3 months? 6 months?
Well, that's the gamble, isn't it? And it forces Western labs to rethink their whole approach. You can't plan a 2-year roadmap for one giant model anymore. Alibaba is basically making specialization an instant commodity. Their bet seems to be that by optimizing for narrow, high-value tasks, perfect math, real-time translation, they can grab market share faster globally. It's prioritizing deployment speed, maybe over those huge fundamental research leaps.
That makes a certain kind of sense. But this speed, this flood of models, it brings us straight to a big problem in the whole ecosystem. How do we even know which of these things is actually better? The traditional leaderboards struggle to keep up. And honestly, maybe they're not even telling us the full story about performance anymore.
Yeah, that evaluation question is critical, which is why Scale AI launching Seal Showdown is pretty significant right now. They're positioning it directly to challenge the dominance of platforms like El Marina. El Marina has been the go-to, mostly because of volume.
Okay, so how is Seal Showdown different? How does it try to fix that potential bias?
Well, they leverage Scale's huge global network of contributors. We're talking 100 countries, 70 languages. The rankings come from actual user preferences, collected through voluntary voting in their free Playground app. But here's the key difference. This is really relevant for you, the listener. The leaderboards are segmented by user demographics, like age, education, language.
Segmented by demographics. Okay, that is a big deal. It means we move away from this idea of one single best model for everyone. So instead of one ranking that might skew towards, I don't know, highly educated users in California, you could actually see which models work best for, say, someone in Europe needing coding help.
Precisely. Or a user in Asia focused on creative writing in their own language. It gives you that granular view, that context we really need.
Yeah.
It forces us to ask, which model is best for this job? Or for this user? Performance depends on context.
Right, performance isn't absolute.
But it does raise another question, doesn't it? If you segment everything, do you risk creating silos? Does it make it harder to compare core capabilities across different groups?
That's the trade-off, I guess. More accuracy for specific groups, but maybe the big picture gets more complicated. We lose that simple single ranking. Okay, let's pivot now. From the software and the scoring to the actual physical foundation needed for all this. Sam Altman's recent blog post detailed OpenAI's infrastructure plans, and the scale is just staggering.
Altman's argument really boils down to scarcity. Limited compute, he says, forces these impossible choices. Like, do you use resources to cure cancer or to roll out universal AI education? He argues you shouldn't have to choose. And the only way to remove that limitation, according to him, is massive infrastructure expansion. Get rid of the scarcity.
And the numbers they're talking about, they're huge. Can you put that capacity into context for us?
They're planning infrastructure that can produce 1 gigawatt GW of AI capacity.
1 gigawatt weekly.
Yeah. To give you a sense, 1 gigawatt is roughly enough power for a small city. So they're talking about generating the compute power equivalent of a small city every single week. It's immense.
Wow.
And this connects to the bigger picture, right? It follows NVIDIA's massive $100 billion investment announcement for infrastructure projects. OpenAI itself is boosting its infrastructure with 5 new AI data centers. That's set to increase the total capacity for the proposed Stargate project to an incredible 7 gigawatts overall. This isn't just buying more servers. It's like building new AI-focused power plants.
But dedicating 7 gigawatts, that needs tens, maybe hundreds of billions in capital. Isn't that a colossal risk? Yeah. Aren't they potentially locking themselves into today's hardware architecture too early, before we even know what the next chip generation looks like?
It is absolutely a massive commitment. And yeah, it's a gamble on the future architecture. But by securing the capital and the compute at this scale, they're basically trying to turn those big philosophical questions, what AI should do, into engineering problems. They're betting huge that the current path, specialized GPUs, data center designs, will hold for a while. This lets them chase multiple AI moonshots at once, instead of rationing compute like most others have to.
And this involves building huge physical sites all over the place.
Absolutely. It's happening now. Oracle's developing 3 of those new sites in the U.S., Texas, New Mexico, the Midwest. SoftBank's handling 2 others in Ohio and Texas. It really changes the game. AI progress becomes less about just algorithms and more about logistics, construction, securing power grids. It shifts the landscape towards potential abundance. But maybe only for the players with the absolute deepest pockets.
That definitely reframes the whole AI race. Okay, let's slow down just a little for a quick roundup of some other interesting things happening this week.
Sure. Let's start with a fundamental engineering story. Microsoft. They published a breakthrough in cooling AI chips. They're actually etching tiny liquid channels directly into the silicon. This hyper-localized cooling apparently gives 3 times better heat removal. Could be a real solution for the melting GPUs problem in big AI systems.
That tackles a core physical limit. Interesting. And on the creative side, for developers, Claude Code got an upgrade. It can now apparently read Figma mockups, analyzing all the design elements, tokens, layout rules, and generate front-end code directly. A smoother path from prototype to code.
And in the audio space, some ex-Google developers launched an app called Hux. It's an AI audio assistant. The hook is that it generates interactive, real-time AI podcasts from your own stuff, emails, calendar, news topics you choose. So you build these live stations with AI hosts discussing your updates. Makes listening feel more active.
Interactive podcasts and music generation keeps accelerating too, right? Suno released version 5. They're claiming a new state-of-the-art performance, apparently by a big margin. Plus, better audio quality and more creative controls.
Yeah, that space is moving incredibly fast. And one more on the visual side. Google Labs launched Mixboard. It's an AI concept board. Helps you visualize and refine ideas using text and images. It uses their Nano Banana editing model, letting you sort of brainstorm and tweak concepts visually with AI assistance, like a dynamic whiteboard.
Okay, and one last piece. A big national strategy announcement, Abu Dhabi. They've unveiled a plan to become the world's first fully AI-native government by 2027. Planning over 200 AI solutions across the public sector, setting a pretty ambitious goal there. All right, let's wrap up with a practical focus. Today's trending tools you might want to check out right now. For that state-of-the-art music generation, you heard it. Suno V5. And if you need to handle diverse multilingual data across different formats, Qwen 3 Omni from Alibaba is their big new omnimodal model.
For sales professionals, take a look at Ruby. It's an AI tool designed to help close deals faster. Gives you research and strategies for prospects quickly. If you work with audio a lot, Audio Convert offers instant transcription, turning audio into searchable text.
For visual creators, Visual GPT aims to put creation, editing, and enhancement all in one place. And finally, pushing video generation. Ray 3 focuses on generating high-quality 4K video with HDR and some intelligent reasoning built in.
So, thinking about everything we've discussed, the sheer scale of physical expansion that 7 gigawatts OpenAI is planning, and these aggressive, specialized model releases from labs like Alibaba. Here's a final thought for you to mull over. How much will the actual physical geography of compute power start dictating where the future centers of AI research emerge? Will access to cheap, abundant electricity become the ultimate factor deciding who holds the technological edge in the next, say, 5 years?
That really brings it back down to earth, doesn't it? Down to the power grid. Well, thank you for joining us for this deep dive into the AI frontier this week. If you found this useful, please do follow AI Brief to stay informed quickly and thoroughly, and maybe share this deep dive with anyone else you know who's trying to keep up with this rapid pace of change. We'll see you next time.